So shim video of how to shim an AEG gearbox. In this example, I'm using an ICS M4 because they have a nice split gearbox and it's a lot easier to work on and a lot easier to show other people. First thing you want to do before you actually shim a gearbox is check that the condition of it is alright. So you want to check that the bushings or bearings are set correctly. You take the gearbox, you look at the bushings, are they damaged? Are any of the holes worn oval or worn out? Then you turn it around and you have a look down the side of the gearbox and you look at the bushings and you check that they're all protruding the same distance and that they're all protruding in an even amount left, right, up, down, or whatever. This is to make sure that the bushings are actually set fully in and that they're not set in a wrong position, because obviously that means it's loose or that it can give issues with actually getting the gear to spin properly. Additionally, you want to check that the bushings or bearings are actually properly installed. How to install bushings and bearings, I'll probably cover in another video because that's a long topic. But just a quick check is that you take a tool and then you bang it with like a medium amount of force on the bushings from the outside. And if they pop out or loosen or whatever, then that's a no-go and they need to be reinstalled with the appropriate bonding agents or interference fit. But as I said, that's for another day. Right. So we assume that you have a gearbox shell with bushings or bearings ready to install gears. First thing you do, clean out all the stuff, all the grease, ETU, cables, trigger, safety lever, tappet plate, everything. That's the best way to go about shimming. The reason why I remove even the tappet plate and safety lever is so you have proper access to the top bushing for the Sectorgear. Well, bottom bushing. So everyone has their own process of shimming. The process I have developed is a bit tedious, but it's a mix of guessing and checking. And the goal is to have a result that is 100% correct while trying as much as possible to cut down on all the boring extra checks. Like if you take a gear and you put it in and you put one shim on and you put the gearbox on top and you go, oh, it's too loose. And then you put another shim on and you do this like 12 times per gear. That's going to waste a lot of time, especially if you put screws in. So for me, it's a mix of guessing and checking at the end of guessing. So there's a process of shimming the gears, and that's important because sometimes you have to make compromises due to factory tolerances. So first you take the Spurgear and you install the Spurgear in the gearbox and shim it. Then you shim the Sectorgear. Then you put the Spurgear in and the Sectorgear in, and you check that these two gears are set correctly and they can function within the tolerances. I'll explain that later. And then the last step is that you install the bevel gear and shim that correctly. So first, Spurgear. So just to explain, here I have 0.1 shims and here I have 0.45 shims. You can work with different sizing of shims. If you only work with 0.3 to 0.5 shims, it's going to suck. You'll want to have 0.1 and 0.5 at least, or even better, 0.1, 0.2, and 0.5. You can also occasionally meet 0.15, 0.25, 0.35. Sometimes it's just manufacturing tolerances of the shims themselves, whatever. It can be a bit of a mess, but generally you want to have a mix of very small ones and very big ones. If you only have two types like me here, 0.1 and 0.5, it's pretty easy to tell them apart. With experience, you will learn how to tell if something is a 0.1 or 0.2 depending on by looking at it and seeing how thick it is. So for the Spurgear, I want to shim it as low as possible, but not too low. So I know I usually need to start out with around 0.2 on the bottom of the Spurgear. So I'm just going to add 2 0.1s. Because I don't have any grease or lubricants on these gears, that means that the shims, they fall off really easily. So be careful with that when you move them around. But I recommend that for shimming, you don't have any lubricant on because the lubricant can interfere with how you perceive the tolerance remaining. So I've now put 0.2 on the bottom. Then I take the top of my gearbox shell, put it on, and I check to see how much slack there is in the gearbox. Or rather, how much slack there is in the gear. Now, I'm using a split gearbox, so it's really easy for me. And it also allows you to see what I'm doing here. But if you have normal full-size gearbox and you can't really see or interact with the gears, what you can do is you can take 1 to 2 screwdrivers and You take one screwdriver, put it on the bottom, hold the gearbox vertical. Then you take the other screwdriver and hold that on the top of the gear. And then you move the gearbox up and down. With this way, you have a very good control of the gear, and you can very easily feel if it's loose or whatever. So this also works great with if you have lubricant or obstructing what you can feel. Now, before you do that, you would want to put the screws in the gearbox. There's two reasons for that. One is that it's difficult to hold the gearbox and a screwdriver and another screwdriver. Okay, but another thing is also that when you put the screws in the gearbox and tighten them, the gearbox will often sit a bit tighter around the gears. We're talking like 0.1 to 0.2 usually. Occasionally you have a gearbox that has like no difference in the shimming tolerance when you tighten the screws, and that's great, but you should expect to have 0.1, 0.2 difference. Right, anyway, so I look at the gear and I can see, I would say it's not a lot actually. Normally it could be like a lot more than this. It could be 0.5, 0.7 that it's missing on the top. Usually you have a whole millimeter of total shim tolerance, both sides combined. In this case though, not so much. Let's try with 0.3 and see what happens. So, 3 shim. Now there's 0.2 on the bottom and 0.3 on the top. And yeah, now the gear is too tight. It's spinning, especially if I don't clamp the gearbox. It spins okay, but if I clamp the gearbox, it stops way faster. That tells me that now it's running too tight. Now, you could clamp this gearbox down and spin it and be like, oh yeah, it's probably working. But it's not. It's running too tight, and that can cause an increased current draw and strain on the motor and battery, low rate of fire, all that stuff that we don't want. So, in this case, it's rather simple. I just take 0.1 off because it's almost there. It was like spinning, but slightly tight. So now it's taking 0.1 off. I have 2 on the top, 2 on the bottom. And immediately, I'm squeezing the gearbox, and immediately you can see now it's spinning freely. So now we shimmed the spur gear, but we want to just double check, because if we just assume that it's running correctly and then put all the gears in and close the gearbox up, we might have a gearbox that is actually running tighter once the screws are screwed in. So now I'm just testing this one gear before I move on to the sector. And I can see that it's still spinning here. And also, if I move it on camera, you can probably see there's a little bit of movement. Now, an important note is there's also a sideways tolerance in bushings and bearings for that matter, but in bushings there's also a sideways tolerance, and that can sometimes, when it's really tight and you're working with really small tolerances, that can sometimes look like the gear is loose, but it's actually shimmed tight and it's just moving this way instead of in and out. So don't get tricked by that. This might seem a little loose. This is actually pretty tight, and I could probably run it even looser than this and it wouldn't be an issue. Okay, super. So just check there's no shims laying around here. Take the gear out, and there's a shim hiding there. You notice how I always put the gears in the same position. This is so in case that I'm working and I pick up a gear and there's a shim left like this, well, then I know where it's missing. Really good trick, because sometimes you've been working for an hour or two, you put the gearbox back together, you look at the table and there's like 2.5 shims laying there, and then you can start this process over. So yeah, not fun. Well, a lot of what I suggest can seem overkill, unnecessary, but I made enough faults and you get to solve it in a way where you don't make my mistakes. So that was the spur gear. Let's do the Sectorgear. Now, I'm going to cheat a bit. I already know that because I put 0.2 on the bottom of the spur, I probably need to start out with 0.2 on the bottom of the sector as well. So I'm just going to do that. Then I'm going to check how much is the total tolerance for that gear in this gearbox. You can see here, it moves a lot. I would say that's around 0.4, 0.5-ish. Yeah, let's try that. So I could use a complete 0.5 and just put that on, and if that's perfect, then awesome, I only used one shim. But the problem is, if at some point I want to adjust the height of the gear after it's been installed perfectly, well, how do I move it 0.1 or 0.2 up if there's a 0.5 on the top and that's all there is? Well, I would have to take the 0.5 off and then put 0.1s on, and that will result in me having to maybe actually redo the shimming on it, because sometimes if you take 5.1s, they're not always the same diameter as 1.5. There's some tolerance in the shims as well. So I recommend that you always finish off having a couple of 0.1s and 0.2s on each side in case you want to adjust it in the future. Anyway, let's try 0.4 on the top here. So now there's 0.2 on the bottom and 0.4 on the top. There we go. Let's see how that works. So I was guessing 0.4, and yeah, that's actually pretty good. Yeah. That is... So you can see that's spinning pretty much perfectly, but if I get it to be perfect, then I should definitely test with screws and see if that doesn't make it too tight. So now, after having guessed, I'm doing the final check with screws. That's spinning fine for an ungreased bushing for sure. And the amount of slack? Probably 0.05 or 0.1, I would guess, which is just fine. You don't have to be like within 0.1, honestly. You just have to make sure that the gear doesn't interfere with other things in the gearbox. But it doesn't have to be super, super perfect. It's just that it's nice to aim for perfection, because sometimes you have to work with really tight tolerances. Especially, and this happens sometimes, Crytek gearboxes and some other ones, they do not have a lot of room to work with. And sometimes it's like, yeah, if you move a gear 0.1 down, it's too tight against another surface. If you move it 0.1 up, it's too tight against another gear. It's like super tight sometimes. And that's when it's a benefit that you already optimized all the tolerances and nothing is loose inside. So Sectorgear is done and Spurgear is done. Now, before moving to the Bevel gear, I'm just going to check the Spurgear and the Sectorgear together. That's a step that's a bit different than just the individual gears. Oh, we have 2 escape shims. Not on my watch. There we go. Don't look at them without the top shell on, because they're wobbling and you cannot know. So don't even try. Boom, top shell on, and let's see how they fit. Whoop. So these gears are definitely not spinning as they should now, right? So both gears definitely are shimmed correctly in the gearbox. That gear is perfect, not too tight. That gear is perfect, not too tight. But when I put both in, they don't run loose as they should. Now, and you can even hear it. It sounds like... I'll let you hear in the microphone. So that sort of sliding noise, well, that comes from the Sectorgear sliding over the big flat surface on the Spurgear. And that's a classic contact point between these 2 gears, and pretty much the only contact point you have to worry about. Right, so what do I need to do now? Well, I need to move the Spurgear down, or I need to move the Sectorgear up. Since I only have 0.2 on the bottom of the Spurgear, I'm not really fond of moving that further down, because it can start to hit the gearbox shell or the edge of the other bushing here down at the bevel. So let's keep it there for now. What I can do then is I can move the Sectorgear up. So let's try that. That also has some disadvantages, but I'll explain that in a moment. So I'm just going to move 0.1 around here. And again, it's a bit more difficult when there's no lubricant on the gears. The shims really want to fly around, but I guarantee you it's still a better way to do it. You can always grease it later. Okay. Ah, see, now it's spinning better and it doesn't have the sliding sound. I'll let you listen on the microphone. Now it still has a sound of something being loose. That's fine. That's just the gear teeth clacking like this against each other when you spin it, because they're not under tension from the spring down to the motor. But that's not a sound that's there during normal operation, so just ignore that one. Now, an important note though is you have tolerance in the gears. So just because now it's spinning loose doesn't mean that it's not touching the spur gear anymore. So what I usually do is I check it this way and then I check it this way. I would turn it around and then I see if that makes a difference, because there is a tolerance and sometimes the gears are loose, but then if you push them together, you can still feel them touching. And I mean, because it's an ICS gearbox, you can also have a look and see if they're touching. That's a bit of a cheat code with ICS gearboxes. Great for video, great for me. Not everyone has it, unfortunately. So looking at this, even though they're spinning freely, they are still touching. So I'm going to try and move the Sectorgear up just a bit more. Another way you can check if the gears are touching is that you take and put a thin layer of grease on the top surface here on the Spurgear. And then if the Sectorgear is touching the surface, you can see a spiral pattern appear in the grease on the surface. But now I'm doing it without grease. So, all right, so I'm going to move this up 0.1. Yeah, well, it still spins the same, but when I move it upside down, it spins a little bit better. And I can also see that there's a slight light gap through the gears. So that's optimal. Now, at this stage, you should put in the screws and just double check, but don't really have to because you already checked them individually. So now I take both gears out, put them in a safe spot. And now we come to the difficult part, and that is the bevel gear. Now, before I go to the bevel gear, I'll just explain why I did this process first with the Sector and Spur. So the issue you have with a Sectorgear in a gearbox and shimming it is, if it sits too high, right? If you put too many shims on the bottom here, you will have issues with the piston. So the teeth come up here and then they grab the piston and pull it back. Great. But as you notice, the gap here between the piston and the sector teeth is really small, because with a lot of these aftermarket gears, they are thicker. Simply the discs in the gears are thicker. They're thicker in the spur gear and they're thicker in the sector gear. And that means that the sector gear, because it sits on top of the spur gear, ends up sitting taller than stock gears. If you ever taken a gun apart, especially the one that's been upgraded by someone, and you look at the piston, and you see that it looks like a chihuahua has been in between the teeth and biting the inside of the polycarbon body here. Well, that means that the sector gear has been sitting too tall. So, to avoid that issue, shim the spur and the sector as low as possible from the start. And then you only shim the sector up as needed. And I'll tell you, I've had some crazy examples with this. I've had gearboxes where I shimmed everything as low as I could, and the sector was still too high. And I have sometimes taken sectors and actually grinded off part of the teeth here on the top. So like removing 20% of the teeth on the top so it doesn't bite into the side of the piston. Because these modern sector gears, they are like 5 times stronger than they need to be. So you can remove some material up here if you need to. But that's not something you should do or practice. I'm just telling you how crazy it can become sometimes and why you should have a process where you optimize that tolerance to begin with. Another thing is also the tappet plate sits on top of the sector gear, and if the if the sector gear sits too high, it can actually squeeze the tappet plate between the top gearbox and the sector gear itself, and I've seen that happen too. So yeah, shim it low, get low. Okay, so that was spur and sector. Let's go for the bevel gear. So the bevel gear is actually the most difficult to shim. This is because the bevel gear has to interface with the pinion gear on the motor. And you can see that if you shim this gear too high, well, then the motor can't get properly in. If you shim it too low, the motor can't grip it properly and will just go all the way in and jam. It's really difficult, especially since none of us humans really have X-ray vision, at least not when we work on AEGs. If someone out there has an X-ray machine for this, let me know, okay? Well, what can you do instead then? So with the bevel gear, you're not really aiming to shim it towards just one side to begin with. What you want to do is sort of get it in the middle of the gearbox. I'm not going to put any shims on. I'm just going to shim it up so it sits with equal on each side. And this is the top of a bevel gear. This is the bottom of a bevel gear. People swap that around all the time, me included. Apologies. Bevel gear in. And you notice there's no shims on. Now with most gearboxes, you have an opening here on the side, so it's pretty easy to see. I'm just going to lift it up and down. And this is why I don't put grease on. If there was grease on, the gear wouldn't fall up and down by itself so easily. I would say that's like 0.2 per side. Let's try with 0.3 per side and see where that gets us. Actually, I'm surprised I haven't used any 0.5s yet. I think these gears and this gearbox is a lot tighter than what you typically experience when installing aftermarket gears. It can vary a lot. Sometimes the bushings sit higher, sometimes they sit lower. Sometimes the base tolerance of the gearbox is just tight. Crytek, I think, are really tight. But usually you would have a good 0.5, 0.7 on each side of a gear. So that was 0.3 on each side. Well, let's see where that gets us. So it's a bit more difficult to see this gear, but it doesn't move at all. If there's no clicking sound at all, and especially you can put a finger on top so it touches the axle and pushes the axle and the gear down, and then you push against it and you can feel if the gear actually moves at all. But in this case, because I can't feel any movement and because I can't see or hear any movement up and down, when I move the gear, I already know it's too tight even if it is spinning loose. And I don't need the screws in to tell me that. So I'm going to take 0.1 off the bottom, which is this side here. So now there's 0.2 and 0.3. So let's see how this one goes. Yeah, now I can feel it's just barely moving up and down. I can feel it and I can hear it. I'll see if I can let you hear it on the microphone. Now, that is a really tight fit. Honestly, you wouldn't find this kind of tight shimming in a normal stock gun. And honestly, they don't really need to. We're just going for perfection, because when you go for perfection as the default choice of the process you use for shimming, it makes it a lot easier to shim in those cases where it's really difficult. So now with the screws in, it's still moving. Yeah, so that's fine. And it's difficult to spin it, but obviously with an ICS gearbox, you can just spin it like this. Oh, and if you like this shim video, let me know in the comments. Let me know how you do it, or any crazy shim jobs or AEGs that you've had to work on, or maybe if you have any issues with your own AEG, let me know, and maybe I will make something that's relevant. So we haven't shimmed the bevel gear, we only just put it in the middle. Now, the way to actually shim a bevel gear is that you manufacture the whole gun in a factory and you have all the tolerances and all the drawings for everything, and then you know how the motor and the gear and the gearbox and the receiver sits together. We don't have that opportunity as technicians or customers working with aftermarket parts. So for us, there's a bit of trial and error with the bevel gear. There is various tricks to it. Some people, they drill a hole in the side of the gearbox so they can look into it and see where the motor stops and so on. It's a bit of a longer process. I'll probably make another video that explains how to do at least the best as you can with normal tools, how to shim the motor and the bevel gear together. The best thing you can do is use original gearbox, original receiver, and original motor grip. When you do that, you have a way higher chance of the motor and the bevel fitting properly together. And it matters. I remember working as a tech, and many times I would have people come in, and I'd ask them, "Is everything there?" And they're like, "Yeah, everything is there." And I'm like, "Yeah, okay." And I get it, and I actually look at all the parts, and of course something is missing, but also it's like receiver, gearbox, motor grip, end plate, everything is like 4 different brands, and none of it was ever meant to fit together. And it's all AEG M4 and all version 2 gearbox, but I tell you, it does not always fit together. So if you have issues with a gun that's whining no matter what you do, check that you're using the original AEG grip, original gearbox if you can. I mean, sometimes it's broken, and if you put a retro arms in, yeah, that's cool. You have a CNC aluminum gearbox. It's lightweight, it doesn't break, but it might not fit as well as the original gearbox. So, and you know what? Standard AR grips are pretty good too. Right, that was a sidetrack. So back to the bevel gear. You shim it in the middle of the gearbox. Then you take the gearbox, you hold it, and then you look straight down the hole, and you look at the lower edge here. When you look over this lower edge of the gearbox, you can see the teeth of the bevel gear, and by looking at how far they protrude, you can estimate if the height is right. Now, this is something that's quite complicated because you have to hold the gearbox at just the right angle. The right angle to hold the gearbox is, you look at the surface here, then you slowly tilt the gearbox, and then just at the point where it disappears is the correct spot to look. This is a bit difficult to simulate on camera, but you get the idea. The amount of teeth you should be able to see is about the middle. If you can see the bottom of the teeth groove sticking up over the edge, then the gear is definitely shimmed too high, or rather too low. But this is something I will definitely prepare better for a future video, so stick around for that and subscribe. Now that we have shimmed all gears individually and the spur and the sector together, we come to the final part, which is we put all the gears in. All these gears have been checked to work individually, and the spur and the sector together has also been checked to work. So now we're going to check that the spur gear and the bevel gear work together. Very occasionally, you will have a bevel gear that sits too high, that's technically too low, on the spur gear. And it's spinning. Now, because you have all 3 gears in, spinning the gear set is going to feel heavier. That's just fine. You are going to hear a rattle. And that rattle is perfectly normal. Again, that's because there's no tension on the system. What you're listening for is if there is sort of like sliding sounds, or you can feel a rattle that's coming from the gears hitting something else in the gearbox. They do that sometimes. Sometimes the sector gear can hit the cutoff lever itself. Sometimes the spur gear can hit the anti-reversal latch. Also kind of rare, but it does happen if you install upgraded anti-reversal latches. So that seems fine. That seems fine, yeah. And you can always, now if you get to this stage and you're like, oh, it's not spinning as freely as it did before, and you're like, well, what gear is stock and so on. Well, you can take a screwdriver or whatever, and then you just gently prod the individual gears. And like, for example, if the spur gear is stock, I'm holding it now, so the spur gear can't move. So therefore the sector gear can't move, but I can still rattle the sector gear a little bit. And if it has this little rattle while another gear is stock, well, then you know this gear is loose and this gear is probably the one that's stock. And vice versa, you can do the same thing with the bevel gear down here. See, I'm holding the spur gear, and I can still move the bevel gear. So, awesome. One well-shimmed gearbox, at least until we try it. So, one final detail is bearings. The process for shimming bushings and bearings is the same process, but when you test for how tight the shells sit around the gear, they have to sit looser with a bearing. A bearing can seem like, oh, it's spinning completely fine and free, but it's actually set too tight. And what you do is that you check the gears individually, then you just gently rock the gear back and forth with a screwdriver. And if you can feel a sort of like tick, 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 tick feeling in the screwdriver when you're moving the gear, then it's too tight. And you'll find quite often that with bushings, it goes from completely locked up to pretty loose in like 0.1, 0.2. But with a bearing, it's completely locked up and then it goes to loose, but it's still ticking 0.1, 0.2, 0.3. Sometimes you need a bit more slack than you do need with bushings. It's more of a sliding scale and you want to be completely out of it. So that means that all the gears actually have more tolerance to move up and down. So that means that when you're using bearings instead of bushings, they do require a bigger tolerance to each other. For example, the Sectorgear and the Spurgear, if you want to make sure that they can never actually touch each other on the surfaces, well, then you need way more tolerance this way and that way with bearings than you do with bushings. That doesn't mean bearings are bad. You just have to think a bit more when you shim them. Right, I hope you enjoyed this video. It got quite long, but honestly, there's no easy way around shimming. You either do it fast or right. If you want to see more videos like this and you enjoy my ramblings and long talks on these subjects and maybe some war stories from jobs I've had on this, then let me know in the comments and subscribe so you don't miss them.